instability. While decision trees offer simplicity and interpretability, versatility, they certainly do have some drawbacks. One is that they're quite unstable to something called rotation, and this figure shows that quite well. So let's say I have two pieces of data. I have blue squares and I have purple diamonds, right? I can build a decision tree with a depth of 0 or 1 depth that perfectly classifies those. However, if I take that exact same data and I just rotate it 45 degrees about the axes, then I now have to have a decision tree with an extra depth to classify that exact same data. And because decision trees are always going to be classifying things orthogonal to their axis, anything that is not perfectly orthogonal to the axis can create a big challenge. And so what we want to do is develop mechanisms that allow us to rotate our data to help reduce instability. One way that you can do this is you can pre-process your data. And a principal component analysis, PCA, gives you a way to mitigate those issues by reorienting the data to a orientation that is more stable. Another thing that happens with decision trees is that they're sensitive to small variations in training data. So even just a small amount of data can really throw them for a loop. So they don't regularize well, which is something that we've been talking about, which is our need to impose constraints is because they, as an algorithm, do not natively regularize well. For instance, changing the seed, just the random number seed, for two different setups can result in quite a lot. So what we'll show now is what happens when you have two different number seeds. So this is seed number 1 in Python, and you can see that I've built a depth 0 and a depth 1, and it classifies their setosa from the versicolor and Briginsia very well, actually. But this is what happens if I give it a depth 2, which is a very different classification method. Mainly the depth here is going off petal length instead of petal width. So while actually it probably classifies just as well, this would be more stable because you have greater distance or distance to your support for an individual data set, right? So there is a fair amount of instability in decision trees. And because of that, often what we'll do is we'll merge those together into something called a random forest.